All right, we just need to finish up this closure packet. So I'm on the very last page here, and the directions say determine each limit. Sketching a graph or making a table may help. In some cases, it'll help. In some cases, it's just, it'll be unnecessary to do that. So let's take a look. So the limit of this function, x cubed plus 2, as x approaches 4. So in this case, we're just going to go ahead and input the value of 4. So 4 cubed plus 2, and the total there is 66. The next one, it's not simplified, so we're going to start our work by, or in its simplest form, so we're going to start our work by factoring what we can. So the limit of this function as x approaches 5, we're going to go ahead and factor the numerator. So we need x minus 5 and x plus 3, all divided by x minus 5. And if you remember from this step, we'll go ahead, we see that x minus 5 and x minus 5 simplify and they divide to give us 1. So we're simply left with a limit of x plus 3 as x approaches 5, which means we'll just take 5 plus 3, and that gives us 8. The next problem is a great one to go ahead and graph. If you remember h and k as being our asymptotes for this graph, so I'm going to go ahead and draw a vertical asymptote at x equals -1 for that h value, and I'm going to draw a horizontal asymptote. It's been a while since we've done these, but just as a refresher, at y equals -3. And if we remember, we have these two branches that get close to our asymptotes but don't actually touch them. So the question is, what's the limit of this function as x approaches -1, but we're thinking of -1 from the right. So if I'm going from the right and I'm approaching -1, what are those y values approaching? And the answer is infinity. For the next problem, I'm looking at the same exact graph, so -1 and -3. I'll draw my branches. Now the question is asking, what's the limit of f of x as x approaches infinity? So as my x values get larger and larger and larger, what are the y values approaching? And the answer is -3. For the next problem, if we think of this graph, we don't have well, I guess the vertical and horizontal asymptotes are at 0. So here are the two branches. And the question is, what's the limit of 1 divided by x as x approaches 0, but from the left? So as x approaches 0 from the left, as I follow this graph, the y values are approaching -infinity. The next one, it's very similar to b. We want to go ahead and simplify the expression, the f of x, and then evaluate. So if we do that, the numerator factors to x plus 3, x minus 3. The denominator factors to x plus 3, x plus 2. So I notice that I can divide these. They reduce to 1. So we have the limit of the quantity x minus 3 divided by the quantity x plus 2 as x approaches -3. So at this point, we'll input -3. So -3 minus 3 divided by -3 plus 2. So our answer here is -6 divided by -1. So our answer is just 6. All right, let's keep moving here. Our sine, we're going to go ahead and graph a sine graph. And our our amplitude is 2. We're going to go left 2. We're going to have a midline down at y equals -5. And you might be wondering, why are we just going left 2 and we're not going a certain like pi over 2 or pi over 4 radians? Well, this b value, we need to take a look at that in order to figure out our period. So we take 2 pi and we're going to divide it by that b value. Well, that means take 2 pi and actually multiply it by the reciprocal, which is 2 divided by pi. I'm going to get rid of this here. And if you notice, 2 pi multiplied by 2 divided by pi, pi can cross cancel or cross reduce, and we're left with a period of 4 units. So let's see, I know I have to shift down 5, so I'm just going to draw my graph up here. See how straight I can make this on my surface. Okay, 1, 2, 3, 4, 5. Okay, this is our midline. My preference is I just really like to always graph without that horizontal shift. So I do my entire graph without the horizontal shift, and then I add that horizontal shift in. So let's see, 1, 2, 3, 4. So our period length here is 4, and I know I'm shifted down 5 units. Sine starts at the midline. My amplitude, let's see, my amplitude is 2. So from there, I'm going to move up 2 units. I'm going to go back to the midline, and then I'm going to move down 2 units, and then I'm going to go back to the midline. Oops, did I miss? Yeah. Okay. Okay, there we go. So let's see. I have taken into account the period, the amplitude, the midline, and I'm really close, except now, sorry if you can hear my daughters, they're downstairs squealing. I'm going to take every single one of those points and I'm going to shift it left 2 units. So this point goes left 2, this point goes left 2, left 2, left 2, and left 2. So here's my graph. I should really make sure, it's hard for me to write on this, but I should really make sure that I'm labeling my axes when I'm doing this. And there you go. There is our sine graph. All right, 4 more. All of these questions, you need to look at your trig identities. And the first 2, you're going to look at your angle, sum, and difference identities. And the last 2, you're going to look at your double and half angle identities. So find something that looks like this. Sine A cosine B minus cosine A sine B. And that is sine of A minus B. So what we need to do here, so think of A and B. We're going to take sine of 3 pi over 2 and subtract pi over 7. Another reminder, you only get a basic calculator on Tuesday. So please make sure you can get a common denominator. We'll multiply this fraction by 7. We'll multiply this fraction by 2. Excuse me, 21 pi divided by 14 minus 2 pi divided by 14. So this answer is sine of 21 minus 2 is 19 pi, denominator stays, over 14. Here's your answer. Okay, B, if you look at your sum and angle sum and difference identities for tangent. This is tangent of A minus B. So A is 203 degrees, B is 6 degrees. So in order to write this expression, we're going to write tangent of 203 degrees minus 6 degrees. That is tangent of 197 degrees. And as I'm doing this, you might want to just freeze your screen, or just like pause the video and see if you can find the next two formulas without me showing it first. So this would be a good place to pause. I noticed that if I have cosine squared theta minus sine squared theta, that is the double angle. So that is cosine of 2 multiplied by that angle, or 2 times A. So this is cosine of 2 multiplied by 25 degrees. That gives us cosine of 50 degrees. The last one is the half angle identity, and it's sine of the angle divided by 2. Well, the angle here is 20 degrees. So we're going to take sine of 20 degrees and divide it by 2. That is sine of 10 degrees.